All right, so 1.4 is using our definitions of trig functions. And again, this will just help us try to figure out the 6 different trig functions. So in the last video, what we talked about is we talked about how sine of theta was y over r, and then cosine of theta was x over r, tangent of theta was y over x. And then we said cosecant of theta was r over y, and then secant of theta was x over, oh sorry, not x, r over x, and then cotangent of theta, right, is going to be x over y. So these are all reciprocals of each other. So we have some identities, and these are going to be very helpful later on. So my suggestion would be to make some flashcards with these on here. So we have reciprocal identities. And this also helps us with our calculator, because if you notice on our calculator, we actually only have sine, cosine, tangent. So how can I figure out what cosecant, secant, and cotangent are if I don't have those buttons on my calculator, right? So what we want to do is we want to figure out some identities. So one of the first ones is our sine. So sine of theta will be the same thing as 1 over the cosecant of theta. Okay, and I'll prove one of these out for us. Okay, that being said, cosecant of theta is the same thing as saying 1 over sine of theta. So this is how I can use it in my calculator. Okay, cosine of theta will be 1 over secant of theta, and then secant of theta will be 1 over cosine of theta. So again, calculator. Tangent of theta is 1 over, not the tangent of theta, will be 1 over the cotangent of theta, which means then the cotangent of theta will be 1 over the tangent of theta. Okay, so how can I prove one of these identities? Right, so let's take a look. So if I say sine of theta is equal to y over r, okay, and I can say the cosine of theta, right, the cosine of theta is r over y. So we say this. So sine of theta is 1 over the cosecant of theta. So I'm going to go ahead and I'm going to replace cosecant of theta with that guy. So the same thing as saying 1 divided by r over y. Same thing as saying 1 divided by r over y. Division is the same as multiplying by the reciprocal. So 1 times y over r, 1 times y, just stays y over r. And notice sine of theta is equal to y over r. What happens when we multiply our reciprocals together? So if I multiply y by r and r by y, everything's going to cancel out and you'll just be left with 1. So a great thing about these trig identities is that if you multiply them together, right? So if I say sine of theta times the cosecant of theta, this will always give you 1, right? Because the same thing, sine of theta times 1 over sine of theta, it's sine of theta over sine of theta, which again gives you 1, right? So what else could I say? I could say cosine of theta, again in parentheses, times the secant of theta. That's going to give you 1. The cotangent of theta times the tangent of theta. Again, that gives us 1. Because again, we can replace all of those reciprocals. So how can I use this potentially to to solve using our 6 trig functions? So if I said something like this, I said find cosine of theta if secant of theta is equal to 5 over 3. Okay. Now, if we remember this, right, secant of theta is r over x, right, and then that cosine of theta is x over r. What this is saying is that cosine should just be the reciprocal of this. So how can I test this out, right? So what do I know? I know cosine of theta is 1 over secant of theta, which again, it's 1 over 5/3. It's 1 divided by 5/3, which is the same thing as saying 1 times 3/5, which means that it's 3/5. So again, it's just proving that these are reciprocals of each other. All right, let's try another one just for fun. So let's say, again, find sine of theta if the cosecant of theta is equal to -√3. So again, what do I know? I know that sine of theta is 1 over the cosecant of theta. So 1 over negative root 3. Remember, we always want to rationalize our denominator. So negative root 3 over 3. So again, just another way that we can find this and solve it. If not, by all means, you can use your Pythagorean theorem and find the x and the y's and things like that. All right, so what's really important about trig, right? We have ranges. Hopefully you guys started to notice, especially with the quadrantals, that your signs always has a particular number and was never larger than certain numbers. So we have ranges of our trig functions, and this will help us when we start to create our unit circle, which we'll talk about soon. So ranges of trig functions. So we get to say this. We get to say for any angle theta for which the indicated functions exist. So I get to say this. So the first one, I'll do it in blue. First one says this: sine of theta has to always be between negative 1 and 1. And cosine of theta also will always be between negative 1 and 1. It doesn't matter which one we use. So let me just change my mode to degree. We use my calculator, right? So cosine, pick any number between 0 and 360. So let's pick 55. Notice, less than 1. Cosine of 250. Notice, negative number. Cosine of 180. Negative 1. Cosine of 181. Under. If I say cosine of 179. Again, still under, right? Sine, right, of 99. Again, notice, under 1. So we can plug in any numbers, and we're always going to get numbers between negative 1 and positive 1. Okay? So that's the first thing. The second thing is that if these are our reciprocals, right? So say I get a number. So what's the number between 1 and negative 1 is 2/3, right? The reciprocals of sine and cosine, right, means that this answer will be flipped, which means it's 3 over 2. 3 over 2. Okay? Notice that number is larger than 1. Right? What's another number between 1 and negative 1? How about negative 1/6? Flip this over. I have 6 over negative 1. So the reciprocals of these guys, right, is this. Secant, actually, what I'm going to do is I'm going to put cosecant here. So I'm going to say cosecant of theta is going to be less than negative 1, or, right, cosecant of theta will be greater than or equal to 1. And then I get to say the same thing for the other one. So I get to say secant of theta is going to be less than or equal to negative 1, or the secant of theta will be greater than or equal to 1. So we kind of get other numbers. Okay? And then the last one, right, so the one that we haven't talked about is tangent. Tangent and cotangent are its own separate animals. So tangent and cotangent can equal any real number. It could be 1, it could be negative 1, it could be larger than 1, it could be smaller than 1. Okay? And we use when we're using our 6 trig functions, right? Sometimes we don't have to necessarily draw them out loud, right? But we're going to come up with 4 quadrants. And there's a little acronym that will help us figure out which quadrants sine and cosine will be positive and negative in, right? So this will help figure out what trig functions are positive or negative, or negative, depending on quadrant. All right, so here is the letters. A, S, T, C. So it stands for, right, all students take calculus. I hope they all take calculus, but who knows? So the all, right, A-L-L, stands for this. Everything in this quadrant is always all positive. Okay? The S, which stands for students in this case, will be this. The sign and its reciprocal will only be positive. T, hopefully you got that, is going to stand for take, which means that this will be the tangent and cotangent. And last but not least, this is your calculus, which means that this is your cosine and your secant. Okay, what this is going to help us is kind of figure out which quadrant we're going to be in. So notice that everything's positive here. So everything's positive in two quadrants. So sine is positive in the first and second quadrant. Remember, this is 1, this is 2, this is 3, and this is 4. Cosine is positive in the first and fourth. Tangent is positive in the first and third. So it's always positive in at least 2. Okay, so how can I use this to my advantage? What I can do is I can say find other 5 trig functions if theta is in quadrant 2 and sine of theta is 2/3. All right, so that's what I know. Okay, so how could I use this? So I need to find, I already know what the sine of theta is. It's 2/3. I need to find the cosecant of theta. I need to find the cosine of theta, which means I need to find the secant of theta. And then I need to find the tangent of theta, and then the cotangent of theta. Okay, so what do I know? I know I'm in quadrant 2. So if I quickly draw quadrant 2, so all students take calculus. So that means students, so sine and cosecant are the only ones that are positive. Everything else is negative. Okay, so this one's easy. 3/2. Flip it. How do I find the rest? Okay, well, I know that sine is your y, so 2 squared, plus your x squared is equal to 3 squared. So 4 plus x squared is equal to 9. X squared is equal to 5. So x needs to be plus or minus root 5. But how do I know it's positive or negative? I'm in this quadrant, so this must mean quadrant 2. That means x has to be negative root 5. It's kind of how you're going to go about doing it. So what can I predict from that? So cosine, negative root 5 over your r. Then this will be 3 over negative root 5. Again, we're going to multiply by root 5 to the top and bottom. So this will be 3 root 5 over 5, but make it negative. Tangent. Tangent is your y. So 2 over negative root 5, which means that this is 2 root 5 over 5. Again, make it negative. And then flip this fraction. So negative root 5 over 2. So again, we get to use our properties to kind of help us figure out what is happening. Again, if we wanted to, we can go back and we can use our reciprocal properties to help us and guide us too, if we want to use those instead of just flipping it on our own.